In this video, we will discuss what is instrumentation and control engineering. Consider a tank partially filled with liquid. In conventional method, if an operator wants to know the level of liquid in a tank, usually he has to go all the way to the top of the tank and insert a dipstick into the tank. This dipstick has scale on it, and the wet portion of the scale indicates the level of the liquid in the tank. This method had lot of disadvantages. Instrumentation is a collection of instruments and their application for the purpose of observation, measurement and control. Basic purpose of instrumentation is to obtain maximum output from the industry with minimum usage of raw materials. Instrumentation and control engineering is a branch of engineering that deals with automated measurement and control of physical quantities like flow, pressure, temperature, level, etc. When we apply instrumentation to know the level of liquid in the tank, a level transmitter is connected to the tank and to the control room. The operator can sit in the control room and monitor the level. Now let us learn some terms related to instrumentation. Process variable or control variable. The measured value which needs to be controlled or monitored is known as process variable. Instrumentation deals with measuring and controlling of various process variables like pressure, temperature, flow, level, etc. In this figure, the process variable is level. Set point. The desired value of process variable is known as set point. Measured variable. It is the electronic or pneumatic representation of the value of process variable. Measured variable typically comes from a transmitter which measures the process variable and produces an output representative of it. In this example, level transmitter is measuring the level in the tank. Manipulated variable. It is the parameter that is adjusted to bring the process back to the desired set point. Manipulated variable in this figure is the water entering the tank. Now let us go through the block diagram of simple instrument control system. The first step in any instrument control system naturally is measurement. Anything which cannot be measured cannot be controlled. After the quantity has been measured, a signal representing this quantity is then transmitted to an indicating or computing device where either manual or automated action then takes place. If the controlling action is automated, the computer sends a signal to the final controlling device which then influences the quantity being measured. This final control device normally can be a control valve, electric motor or electric heater. Both the measurement device and final control device are connected to the same process. I will explain the same with an example of temperature control system. Consider the case of an electric oven. When we set a temperature for an oven, a sensor senses the actual temperature inside the oven and transmits a signal to the controller. The controller then compares the signal received from the sensor with the set point or desired value. If the actual temperature in the oven falls below the set point, controller sends a signal to activate the heater to raise the temperature back to the set point. If the temperature in the oven is above the set point, controller sends a signal to deactivate the heater to lower down the temperature to the set point. Next term related to instrumentation is an instrument. What is an instrument? An instrument is a device that is used to measure and control a process variable. An instrument converts the parameter that we need to measure into a readable format. This figure shows some examples of instruments. Now let us see the basic elements of an instrument. The first basic element is the primary sensing element. The primary sensing element receives energy from the measured medium and produces an output that depends on the measured quantity. The output signal of the primary sensing element is a physical variable such as displacement, voltage or current. For the instrument to perform the desired function, it may be necessary to convert this variable to another more suitable variable while preserving the information content of the original signal. An element that performs such function is called variable conversion element. The level of the output from the variable conversion element may not be enough for the next stage. The output of variable conversion element may require a change in numerical value by preserving the physical nature of the variable. An element that performs such a function is called variable manipulation element. When the functional elements of an instrument are physically separated, the data must be transmitted from one another. The data transmission element performs this function. So now the measuring is done and we need to present the data in the suitable form so that it is easily understood by the observer. For this, data presentation element is used. This figure explains how instrumentation is applied to control the level of liquid in a tank. The first instrument in this control system is the level transmitter. The purpose of this device is to sense the water level in the tank and report that measurement to the controller in the form of an instrument signal. In this case, the type of signal is pneumatic, a variable air pressure sent through metal or plastic tube. The greater the water level in the tank, the more air pressure output by the level transmitter. Since the transmitter is pneumatic, it must be supplied with a source of clean, compressed air through the air supply tube entering the top of the transmitter. The pneumatic signal now reaches the controller, that is here the level indicating controller. The purpose of this instrument is to compare the level transmitter's signal with a set point value entered by a human operator. The controller then generates an output signal telling the control valve to either open fully or less so that water flows out from the tank to maintain the water level at the set point. Like transmitter, the controller in this system is also pneumatic, that is operating entirely on compressed air. This means the output of the controller is also a variable air pressure signal, just like the signal output by the level transmitter. Naturally, the controller also requires a constant supply of clean compressed air through the air supply tube. The last instrument in this control system is the control valve, being operated directly by the air pressure signal generated by the controller. This particular control valve uses a large diaphragm to convert the air pressure signal into a mechanical force which helps to move the valve open and close. When the controller is placed in the automatic mode, it will move the control valve to whatever position it needs to be in order to maintain a constant water level in the tank. A human operator running this tank has the option of placing the controller into manual mode. In this mode, the control valve position is under direct control of human operator and it is his responsibility to move the control valve to the appropriate position to hold water level at the set point. So by this we come to the end of this video. If you like this video, please support us by subscribing our channel. Thank you and have a nice day.